So for 4.6, it's called curve sketching. So this was before we had graphing calculators, so you can kind of figure out based on all the information of increasing, decreasing, concavity, uh, first and second derivative tests, you can figure out kind of what it's going to look like. You can sketch it, you can use the intercepts and your critical numbers and etc. to find what the graph looks like. But nowadays you don't really need to do that. But the usefulness of this section of this section um, is that it makes you do everything we've learned in chapter 4 on one problem. So it kind of summarizes everything and we get to apply it to something. But let's just try to keep it together here of summary of curve sketching. All right, so step one. Well, let me write the example first. This will be problem 1 in the homework. Sketch y equal to x over x squared plus 4. So what I recommend is to start off with the intercepts. So step 1, find the x and y intercepts. And at this point, I assume you all know how to do that, but just in case you don't, I'll write a note here for you. Find the x-intercept. Let y equal 0. Basically let, yeah, or your f of x, depending what you got. And solve for x. That's pretty much what you do for all functions. Let y be 0, solve for x. So here we go. So setting this guy to 0. And right away, you should see what the answer is, right? What x value would make this 0? Yeah. The bottom can't be 0. So as long as the top is 0, we're good. So this implies that x has to be 0, which gives us an x-intercept at 0, 0. Okay. Now let's move on to y-intercept. Is that cool with everybody? Do you see why this is 0?
Yes.
To find y-intercept, let x equal 0. This one's easier to find. You just plug in 0 for x and see what you get. So nothing crazy. Then solve for y or f of x. So y would be equal to 0 over 0 squared plus 4, which is 0. So this question is not that interesting because it's going through the center. So technically you have an x and y intercept at the same place, which happens, but the procedure is the same no matter what. You let y be 0, solve for x, x-intercept. Plug in 0 for x, see what you get. That's your y-intercept. Any questions on this idea here. This is our like basic algebra stuff. Just in case you forgot, I wrote some notes for you. Just let me know. Step 2, find the critical numbers. All right. To save time, I'm going to skip the derivative step. So find y prime, which is going to be this. After you do your quotient rule, you're going to get this here. At this point, I'm going to assume you're a derivative expert. And if not, you're going to have to get this yourself. Okay. Stupid Holland shit. All right. So critical numbers, we said you find the derivative, set it equal to 0, right? So do you all agree that this will only be 0 if the numerator is 0, right? The entire thing will 0 out if this top part is equal to 0. So really all we have to do is set this guy to 0. Does that make sense? So this was my critical numbers. Right. So far, you guys still with me? We found the intercepts, which happened to be the same place. And then we took a derivative, set it to 0, found two critical numbers, which could be maximum minimums or inflection points. I don't know. All right. Step 3 then. Find all extrema points. Which just means max min type stuff. Excuse me. So I suggest we do the first derivative test. I don't know why I wrote it at an angle there. Okay. So there's my two critical points. So I'm going to test in the center, before and after. So remember we said to do the first derivative test, just plug in the points into the derivative points before and see if it's plus or minus, right? So f derivative, f prime, or sorry, we called it y. Excuse me. So do you agree no matter what happens inside here, you're going to square it, so it's going to be positive? The denominator? And when I square this guy, it'll become plus, but then there's a minus waiting for it. So do you see how this would become negative 9 plus 4? Which means the whole thing is its own negative. So I don't really care about the number. I care about the sign. So I know over here, I'm negative. Excuse me. All right, so now do this guy. Be a 0. Oops. Yeah, the bottom doesn't matter, does it? This becomes 0 plus 4, which is plus. Okay, cool. If you want to calculate the whole thing and get the number, that's fine. I'm just being lazy because I can already know it's plus or minus. The number doesn't matter. If you plug in 3, that's going to be the same thing as this, isn't? Because when you plug in negative 3, you square it. Plug in negative 3, you square it. So that's the same thing as plugging in positive 3. So it's going to be the same as this one. See what I mean? Oops. There you go. Okay. Sorry, my mind's a little distracted today. So we're going to be decreasing, then change to increasing. Then we're going to go from increasing, right, to decreasing. That's a shitty drawing. So this looks like it's probably a minimum and a maximum. All right. So far, you guys good, right?
Yeah.
So step 4, plug in these values into the original function and figure out the actual point. All right. So y of 2, what's the original function? Oh, here it is. This guy will give us -1/4. All right. So max at 2 1/4, minimum at -2 -1/4. All right. So we got all this information. Now we can sketch it. That was the whole point, right?
How'd you even get the twos? I'm lost.
Oh, I'm sorry. These?
Okay, I see what you did. I see what I did wrong. Thank you.
Yeah, plug into the original to get the location because we already determined that they were max and mins here, right? We just want the point because we got to plot it. Excuse me. Okay. So sketch your graph using all this information. Okay. So we had the y and x intercept right there. We had a maximum at 2 1/4, right? I should probably label that better. It doesn't look stupid. Okay, so we have a maximum right here going upward like this. We have a minimum at -2 and 0.25 about here. something like this. Let me find Desmos and see how good this is. So using the max and mins intercepts, we can get a good sketch. Usually we get better intercepts, but oh well. What's it? Yeah, here it is. Yeah, about kind of got it right. All right, so the main idea makes sense, right?
Yes. What about the points of inflection?
Point of inflection, we would probably end up having it right here.
Okay.
The original function was x over x squared plus 4. So you would need the second derivative in order to get the inflection point, but doing another quotient rule on that is nasty, so I wouldn't do it unless we have to, you know what I mean? Like if the graph is too complicated and we need it, then yeah, just go ahead and find it. But
Okay.
using the
The
max and mins should suffice.
the homework
And then
asks for the smallest and the largest inflection.
what's that?
It asks for the smallest and the largest inflection on the homework.
Oh, did it? I don't remember. Let me see. Oh yeah, forgot about
In
that.
asymptotes too.
Asymptotes, that goes back to college algebra. But we can talk about that. Let's see here. One moment. Let me open the homework up. Hmm. There it is. Okay. Yeah, so we have the intercept, minimum, maximum. Points of inflection, the 0, 0 is the obvious one, but the other two, we would need the second derivative. Because you can see it right here. Looks like it's going from increasing to decreasing, then it changes here, then it changes again somewhere. Yeah, right there probably. Life sucks. We need the second derivative. Oh well. But anyway, do you guys, before we get to that, do you remember how to find the asymptotes? It was a college algebra question back in the day. So anything that made the denominator zero was a vertical asymptote. Can anything make this zero down here? Does a real number exist that would make this zero down here? In the denominator, let me share the screen again. Can you see this? No, this is just not a trick question. You agree that if I square anything, it's going to be any real number, it's going to be positive, right? So if I add 4 to it, it should become more positive. There's no way it's going to become zero down here because I'm always going to be squaring whatever I plug in. So it can't be zero. So since the bottom cannot be zero ever, then there are no vertical asymptotes. So if you had something like this back in the day, right? You had an asymptote at x equal to -4 because that makes the denominator zero, right? So this asymptote, the function is approaching the asymptote, and as it gets closer and closer, it goes to infinity, but never actually crosses it because if it did, it would divide by zero. So that's not going to happen, right? That was how you found vertical. Whatever made the bottom zero was the equation of the line that would create vertical asymptotes. This doesn't have any vertical because this will never be zero. There is no real solution for the denominator being zero. Now, the horizontal asymptote had 3 cases. So basically, it all depends on the degree. If the degree of the numerator is less than the denominator, then it's always going to be this for your horizontal asymptote. Horizontal will always be y equals a number. So, but if the bottom is bigger, the degree, which it is, right? Degree down here is 2, degree up top is 1. So hence this case, y equals 0. If it was the other cases, well, then it changes. If they're equal, then you got to divide the leading terms and see what you get. If the top is bigger, then there is no horizontal, but there is an oblique. Does that ring a bell?
Yeah, that makes sense.
So here they just want to know how many asymptotes you got. Well, we just have the one since there's no vertical. That's why it doesn't cross the kind of approaches the y equals 0 line, which is the x-axis. All right. But anyway, let me find the derivative. Give me a sec. Find the points of inflection. Set y double prime equal to 0. So y prime was equal to this garbage. That means that implies that the second derivative would be equal to excuse me. Square the bottom and do a quotient rule. That's gonna need more space. So it should be derivative of the top, which is negative 2x times the bottom minus derivative of the bottom, which is 2 times this garbage. Times this. Okay. Derivative of that. Times derivative of the inside. Minus is built in. Times the derivative times the top. So it'll be another piece here. All right. Looks like garbage. Let me write that prettier. Currently, I see a couple of things in common. I'm going to factor negative 2x and one of these to make this prettier. You can see why I did the first derivative on the side instead of doing it during this example because it takes time. This will cancel one of those. This will combine. These will cancel. I'll have 8 times 2. That'll be negative 16x over x squared plus 4 cubed. Let me double check everything. Let me see if I have a E for that. 1 second. Looks like it's close, but this top part's not right. You write that better.
Would there be an x, negative x squared at the top? So it'd be negative 16x minus x squared. I think,
Let's see. Double check one more time. Factor this out, and the negative 2x is factored. That's here. This. Oh yeah, this should be. Well, there's one of them here. This one's gone. This 2 is missing. Is that what you're talking about?
oh, I think so. Because I got
This 2x is pulled out, but not this one. And this is still there. So then this changes it. That'd be 1 minus 2, so that'd be negative x squared. Plus 4 times 2 is 8, plus 4 is 12. And then we got that negative 2x out here. Yeah, there we go. Sorry about that. Just skip this part here, but basically you'll end up with this. Once you do the algebra. So here's second derivative, finally. In order to get it, you have to do a quotient rule, but during the quotient, you're going to have a chain. And then you do a lot of fancy algebra to get to here. Now we can talk about inflection. Do you have any questions on the second derivative? If you, I can go into more detail if you want.
oh, that makes sense. It's just a messy problem.
Yeah, that's why I prefer doing these ahead of time to save us some headache, but I forgot about the inflection. Since we've been doing derivatives all semester, I feel like we can get away with skipping this part during lecture. But anyway, you will have to do it though. I will have at least one of these on the test where you gotta do, well, you gotta sketch it. I mean, you can use a graphing calculator to help you out, but you still have to list the inflection points, maximins, intercepts, etc. All right. Finally, that's why they get these numbers. This right here. That comes from setting the derivative equal to, or second derivative equal to 0. And obviously to get the y's, you got to plug it in, you'll get these two. But anyway, any questions on this problem? All right. But you can see they're kind of involved, right? Even though it's, they made it sound simple. Just sketch the graph, dude. And I was like, no, it's not. It's not easy, simple at all.
Yeah, it's just a long process.
All right. Let's do one more of these, but this time I'll be a little more organized. Do example 2. Analyze and sketch. Y equal to x squared over x to the 4th. No, what was it? Squared. Yeah. Plus 12. All right. Step 1. Sadly, this one is a simple for the, it's kind of easy for the intercepts, but oh well. So we'll kind of speed through that part. Find x and y intercepts. So this guy will basically give us 0, 0 again. You guys cool? I skipped that part. Does that make sense? So because it goes through the middle, it's just boring. Move on to step 2. Find the first derivative and the critical numbers. Let's get the derivative this time. Sorry, guys. So what's going to be the critical number here? It should be pretty obvious. What do y'all think? What makes this 0? Yeah, it's the only spot, right? It's a critical number at 0. Just one of them. Oh well. Step 3. Find double prime and the inflection points. The second derivative is equal to negative 72 x squared minus 4 over x squared plus 12 cubed. So inflection points are going to be plus or minus 2, right? All right. Since we have the second derivative, we can use that to help us with the critical value. Plug it into y double prime, the second derivative. Do you agree that it's going to be positive? So if it's positive, what does that mean?
Goes up. Can you hear me?
Yeah.
Oh, okay. I think I was pressing Alt, so I was talking, but I wasn't actually talking.
Oh, we all agree this is a minimum, right? This is the second derivative test. All right. So let's do our sketch. Oh yeah, before we move on, do we have vertical asymptotes? In other words, can the bottom be 0?
No.
No, right? So there is no vertical. Horizontal, we have 3 cases. The degrees are equal, right? Denominator and numerator. Since they're equal, you take the leading term, which on top is x squared, and on bottom is also x squared. If you divide them, you end up with a 1, right?
Yeah, so y equals 1.
So in this case, y equals 1 is going to be the horizontal. So put all that together and do a sketch. Shitty line. What the hell is that? Okay. So let's say 1's up here. 0.5 is here. So my asymptote will be up here. My horizontal. All right. And we have inflection points at 1 and 2. I'm sorry, 2 and -2. We got a inflect, it's called intercept right there for both. And we know that there's a minimum here. Or, yep. And we have an inflection point at 2, but you need to plug in 2 into the original. So y of 2 is going to be 2 squared over 2 squared plus 2, which is 4 over 6. No, sorry, that's a 12. 16, which is 1/4. Y of -2 will be the same garbage. So let's not waste my time there. All right, so we got a point at 2 and 1/4 and -2 and 1/4. So we're going to do this and then something like that. I think. Let's see. We'll graph it in a moment. Some garbage like this. We have an asymptote up top. We have inflection points here and here. Right? And then minimum here. All right, so let's see how close we are. Kind of close, right? Y equals 1, it's right there. Yeah. Let me see if I can adjust the vertical. It's prettier, right? So at -2, it changes from increasing to decreasing. Here and there. But yeah, kind of close, right? Not too horrible. So there is no max. There's 2 points of inflection. Intercept is the same as the minimum, which is true. And your horizontal is going to be y equals to 1. And we had no verticals. Any questions on this sketch? Okay.
I feel like 4.6 is going to take a long time to complete.
Yeah, each one is just kind of long. That's why I'm only going to give you one on the exam because you can easily spend 20 minutes on that. And if the Doritos are a pain, you could spend like an hour on one of them. But I only gave you 11 of them on the homework. but it makes you practice everything from chapter 4 and a lot of chapter 3. So it's not a waste of time. It's good practice. It's just, just work.